Hello students, welcome to Toppscholar, the smart learning app. Today we are going to solve a few questions which will help you in your MHT-CET examination for the subject of chemistry. So here children, the osmotic pressure of the solution of 3.42 grams of sugar, which is having the molar mass of 342 in 600 ml at 300 Kelvin will be option A 0.40 atmosphere, option B 0.41 atmosphere, option C 0.6 and option D here is 0.46. So here we have to determine the osmotic pressure, okay, but we are already provided with certain given information. So we have the molar mass of the solute which is 342, we have the amount of solute that is 3.42 grams, we have the volume that is 0.6 liters, we have the temperature that is 300 Kelvin and R is the constant that is 0.0821, okay. And we already know that if we try to substitute into the formula to determine the osmotic pressure, we have pi is equal to WRT divided by MV. So we have weight as 3.42, R is 0.0821, then we have temperature as 300, molar mass as 342 and volume as 0.6. After substituting the value and calculating, we get the answer as 0.41 atmosphere. Hence, the correct answer here is option B, that is 0.41 atmosphere. So students, an element with the mass number 81, it contains 31.7% more neutrons as compared to protons. So we have to find the symbol of that atom. Option A 8135 for Br, option B 8136 Kr, option C 8137 Rb and option D over here is 8734 Se. So let us see how we are going to answer this question. So we are provided with the mass number of the element which is 81, which says that protons plus neutrons is equal to 81 over here. So if let's take the number of protons which are present over here as x, right? So what will be the number of neutrons which is present? So that will be x plus 31.7 divided by 100 because we are provided that there is 31.7% more number of your neutrons which are present, okay. So 31.7 divided by 100 percentage of x, which comes out to be 2.137x, alright. So we can say that your 2.137x is equal to 81 because total mass of the atom is your 81. So x comes out to be approximate 35. So how can you represent this? So the general representation of the electron, we can write it as x, which is your electron or the element, right, upon Az. So x is the atomic symbol, A is our mass number and Z is the atomic number. Hence the symbol of the element will become Br, which is 8135. So 35 is the number of protons which is present and 81 is the total number of or the mass number of the element, total number of protons and neutrons. So the correct answer here is your option A, that is 8135 Br. So a non-metal that does not exhibit a positive oxidation state is option A O, option B I, option C is F and option D is Cl. So here among the given options which are provided to us, we can see that your fluorine is the most electronegative element into the periodic table and that is going to exhibit an oxidation state value which is just of -1. Along with that, the other halogens which are there and the oxygen, they are also going to exhibit a very positive oxidation state. As well as your oxygen, we can say that it exhibits +2 oxidation state into your oxygen difluoride structure. So hence the correct answer here is option C, that is your fluoride, because it is a non-metal that is not going to exhibit the positive oxidation state, rather than oxygen, I and Cl, all of these are going to exhibit the positive oxidation state. So students, what will be the root mean square speed of methane molecules at 59 degrees Celsius? Option A 703.9 meter per second, option B 719.4 meter per second, option C 622.8 meter per second and option D is 562.9 meter per second. So what we have to do, we have to determine the root mean square. So for this we are going to use the formula. You can represent root mean square by writing it as U RMS, and for that we are going to do the square root of 3 RT by M. So the temperature that we have here is into the form of Celsius. Let's convert it into the form of Kelvin. 59 plus 273 gives you 332 Kelvin. Okay, then we have M, which is 16. Why? Because we are doing the root mean square of your methane molecule. So M will be 16. R is a constant, 8.314 into 10 to the power 7 ERG per Kelvin per mole. So let's substitute the values over here. We have 3, R is 8.314 into 10 to the power 7. The T will be 332 divided by M, that is your 16. If we try and solve the values, we get the answer as 719.4 into 10 to the power minus 2 centimeter per second. So it will be final answer as 719.4 meter per second. The correct answer is option B. That will be the mean square speed of methane molecule at 59 degrees Celsius. So students, we have an assertion and a reason statement. Assertion statement says polymers are micromolecules formed by the repeating structural units. The reason here is the chemical process by which simple molecules or monomers are transformed into a polymer is known as cyclisation. Option A, assertion is correct but the reason assertion is incorrect but the reason is correct. Option B, both assertion and reason are correct and reason is not the correct explanation of assertion. Option C, both assertion and reason are incorrect. Option D, both assertion and reason are correct and reason is the correct explanation of assertion. So here students, when we are talking about a polymer structure is formed when we are adding a repeating unit of monomers. So here the repeating structural units or monomers are added. Monomers are added to it. Okay. So the polymers over here are formed because of the repeating unit of your monomers. But the polymers to which you are creating, those are not created by the micromolecules. Those are majorly made with the help of the macromolecules. So what is a polymer? It is a polymer are formed because of macromolecules which are repeating units or repeating structural units of your monomers. The second statement, the chemical process by which it is formed, it is not known as cyclisation, it is known as polymerization because you are adding multiple monomer unit and that is transformed into a polymer. So that is an example of polymerization. A basic example if we can take is the formation of polythene. Right? So the ethene molecule are added into multiple times, so that's the monomer and it is going to form a polymer structure. So that reaction is known as polymerization reaction. Hence, the correct answer here is option C. Both assertion and reason are incorrect because it is not a micromer and here it is not a cyclisation process, it's a polymerization reaction.